this may be the most important lesson I ever do, so pay attention because this is really good stuff. Alright, I'm going to go through the law of logs, and this first one is really just how you convert an exponential function into a logarithmic function. Here's your base, and here's your power, and here's the answer, well, the value. I'm going to say you can convert between, and you say log base A of C equals B. And all I'm doing is this A goes down, and then you're going to swap these two values on different sides of the equal sign. Now, I hope you remember, like, if you have a to the b times a to the c, it's a to the b plus c. And the reason why that's important is because if you have log base c of ab, that's equal to the log base c of a plus the log base c of b. So, for example, if you had log base c of 3x, that can be log base c, let me rephrase that. Let's make that a 5. Okay. Log base 5 of 3 plus log base 5 of x. The division rule said if you have a to the b divided by a to the c, it's a to the b minus c. So here it's going to be log base c of a minus log base c of b. And I'll give you an example of this one. I'll use a nicer color. How about log base 2 of 4 divided by x becomes log base 2 of 4 minus log base 2 of x. The power rule is really one that I want you to take a look at. And once again, when we had a to the b to the power of c, it was a to the b times c. There's also something else I want you to remember. When we had like a to the b over c, that's the c root of a to the b. And the denominator is your root power. The numerator is the power. I shouldn't say the root power, this is the root. So here, I'm going to get, I take this b, which is my exponent, and I bring it in front, and it shouldn't be a surprise to you, but it's now b times log base c of a. And so if you have, let's say, log of x to the 2/3, that's going to be 2/3 log of x. Now, I'm going to erase all of this. I know I've gotten really fast, so please stop and go back over things. I'm going to erase all of this because the last thing is super, super important, and I'm going to apply two rules at once. Hello, my dear. How are you? How polite. Anyway, so here's what I'm going to do. I'm going to say, what if we had something like 2 to the x equals 5? Well, real quick, if we had x squared equals 5, we'd say x equals plus or minus the square root of 5, and there's your answer. And if we had 2 to the third equals x, well, you just multiply or do that, and you get x equals 8. And there's one other thing I want to show you. If we had something like this, I'm going very quickly. X to the 2/3 equals 16. What you could do is you could raise them both to 3/2 power, and what you get is this becomes 6 over 6, which is 1. And you'll get the square root of 16 cubed, which would be 4 cubed, which is 64. All right. Now, like I said, I'm just going through this really quick, and I just want to point out that you know how to do all those things already, or at least you should. But now we have this question. And the power rule is nice because by using the power rule and the very first rule, which was a to the b equals c, becomes log base a c equals b. That's what I'm going to do first. I'm going to say log base 2 of 5 equals x. Nope, that is not, oh, that's not what I'm going to do. Sorry about that. Oops, ignore. Sorry, I'm trying to move quick. What I'm going to do first is I'm going to log both sides. So I'm going to get log of 2x equals the log of 5. And now I'm going to apply the power rule, and I'm going to move the x into the front using the power rule, and I get x log 2 equals log 5. So step 1 was log both sides. Step 2, move x using power rule. And then step 3 is I'm going to divide by log 2 and log 5. And one of the things I really want to stress is log of 5 and log of 2 are just numbers. They're actual numbers. And I'm going to use my calculator. I'm going to say log of 5 divided by the log of 2. And when I do that, I get x, I'm going to say, is approximately 2.32. And step 3 is going to be divide. And that's it. And so you can do this. You can solve these problems where we have a exponent that you're looking for by using the this rule, or by logging both sides, using the power rule, and then dividing. But I want to show you something else. Oops. And this is called the change of base. And it says the log of a of b equals, and it's just log of b over the log of a. And so you take the base, and that goes in the bottom. You take this number, and it goes in the numerator. Take a look. The reason why that works is because if I started with 2 to the x equals 5, and then I did this, which is what I started to do before, I would get log base 2 of 5 equals x. But log base 2 of 5 equals x, according to the change of base formula, I'm just going to rewrite this like this. It's going to be log of 5 over the log of 2. But that's what we end up getting anyway if we had just proceeded as is. So you can see, here's where I'm starting. But instead of doing all that work, I can thus convert it into logarithmic form, from exponential form to logarithmic form, which was the very first thing I wrote up. And then I can use the change of base formula, which is this. Alright, I hope that was useful. Oh, it's a bit of a long one. Good luck.